The first of the operators in C that we're going to have a look at when dealing with individual bits are the double less than and double greater than operators. We don't call them double less than and double greater than. We call them shift left and shift right. And this is how they work. The double less than sign, which is treated as the shift left operator, is used to shift the entire bit pattern of an integer number a certain number of bits to the left. I'll show you an example of that in a moment. I just want to cover the other operator. The shift right does exactly the opposite. It shifts the bit pattern in the opposite direction, to the right. In other words, take the bit pattern for a number. Let's say the number 5. The number 5, the bit pattern is 101. Now, if you wanted to shift that to the left, say 4 bits to the left, then the resultant bit pattern would be 101, 0000. If you're not sure exactly what I'm talking about, then pause the video at this point and write down 101 on a piece of paper. And then imagine if you actually moved those 3 bits off to the left 4 bits away. In other words, 4 bits to the left. What would happen? Well, you get 4 bits appearing on the right. And that's what you get. Let's have a look at that in a moment. Just before I tell you that, I should mention that when you shift things to the left, the things that appear to take up the positions on the right are all zeros. But if you go too far, well, the compiler doesn't actually specify what should happen if you go too far. And if you go to the right, then the bits just get eaten up, and new bits that are 0 appear on the left. That is defined, that's not undefined. Now, if you don't know what that means, if you don't know what any of that means, then don't worry, we're going to have a look at some examples and you'll see what that means. Now, here's an example. The number 13, if we shift that left 3, we end up with 104. Now, how does that happen? Well, the bit pattern for 13 is as follows. It's 1101. I've got some zeros on the left just to show where the other bit patterns are going to go. Anyway, you'll see what that means. 104, the answer is 011010000. Now, it's exactly the same as what we had above, except that the 1101, which was the 13, has been moved to the left, and it's been moved to the left 3 places. Is it starting to make sense now? 3 new zeros have appeared on the right to take up the space, if you like. And 3 of the zeros on the left have been eaten up. Let's see an example of shifting right. Oh yes, I guess I should mention that what we're actually seeing here is 13 multiplied by 2 to the power of 3 gives you 104. In other words, 13 times 8 gives you 104. Now there's a correlation there. Shifting left 1 place effectively doubles the number, multiplies it by 2. If you do some maths, you'll be able to figure out why that might be. So shifting left 3 will multiply it by 2 3 times, or 2 cubed. Interesting. Okay, now shifting right. 52 shifted right 4 gives 3. How does that happen? Well, let's look at the bit pattern for 52. That looks like that. The bit pattern for 3 looks like that. Now 52 is 110100. If we move that to the right, we actually lose the 0100. That all gets eaten up. Even though I know there's a 1 in there, the 1 still gets eaten, and you end up with just the 11. Now 11 happens to be 3. You can verify that to yourself if you want, just like you can verify that 104 in the top example is that bit pattern that we showed there on the right. And incidentally, 52 divided by 2 to the power of 4 equals 3 if you do that as an integer division. In other words, 52 divided by 16 is 3. Well, 3 with a certain remainder. But we chop off the remainder because we're doing integer division. So you can think of shifting left as multiplying by 2, and you can think of shifting right as dividing by 2. Let's go and have a look at some coding examples of that. Here is shift.c, and you'll find this in the chapter 17 folder. It's a pretty simple program. It's already complete, so I'll just show you what I've written for you. Let's go down into the main. Yes, I know we're doing a little ADX, and I want to standardize on that now. We're going to enter a number, and then we're going to ask the user how many bits they'd like to shift. And we're going to use this question to do it. right here, how many bits would you like to shift? And if they enter a negative number, then I want to shift right. So we'll be shifting left by default. Most of the time we shift left. Shifting right if they enter a negative number. And then we're going to get a result, and then we'll print out the result. So we'll do it like this. If the shifting number that they entered is greater than or equal to 0, then we will shift left by that amount. Otherwise we will shift right by the negative of that amount. By the way, shifting left or right by a negative number is undefined in the C language. That's according to Kernighan and Ritchie. Finally, we print out the answers. So I'll give a number here. %u is used for unsigned integers. Whenever we're dealing with bits, it's really a good idea to treat everything as an unsigned integer rather than treating it as an integer. In other words, we don't really want to have negative numbers involved here. We'd rather go in the range 0 to 4 billion than negative 2 billion to plus 2 billion. So we're going to print out an unsigned integer and then its hex equivalent. If you happen to understand hexadecimal arithmetic, then that might be a useful number for you to look at. And then we'll say how far we've shifted it. We've shifted it left or right, and we've shifted it that many places. And again, the answer will be in an unsigned number and a hex equivalent of the unsigned number. Take a moment to pause the video and stare at that if you're not quite sure what I'm doing here. Okay, so that's going to be the whole program. So let's compile that and run it. Please enter a number. Alright, well, let's use that example used in the slide. So we'll take 13. How many bits would you like to shift? And we'll say 3. We're going to shift it left 3. And the answer, 13, which is actually D in hex, shifted left 3 is 104. And that's exactly what we thought it would be. Which 104 happens to be 68 hex. Just in case you're interested, press enter to exit. Okay. Let's run it again and try shifting right. Please enter a number. Try the number that we had before, 52, was it? I can't remember. And shift it negative 4, so we're shifting right. 52 shifted right 4 is 3, and that's the example that we were looking at before. Okay, let's try it again. Let's try shifting 52, and we'll shift it right. Let's shift it right 9 places. We get an answer of 0 because we've just pushed it right off the end. Okay, well, that's a pretty simple, straightforward example. I encourage you to go and have a look at the code, write your own examples and test that, and make sure you're comfortable with the use of shift left and shift right before you move on to the next module.